Hey, so this is the Spring 2022 Physics 3A Extra Credit 3. I'm Siddhant and I'll be discussing two examples involving cars as they turn with friction. I did this project with Oshini. So the first example is when a car is turning on a flat surface such as a residential street. When this occurs, a centripetal force acts on the vehicle. These turns often have a maximum velocity at which they can occur. So if you take a look at the example with this diagram drawn out, at the non-linear points of the road, there's a centripetal force acting on the vehicle, and it's pointing towards the center of the road, which is the blue circle. And at the straight parts of the road, there is no centripetal force acting upon the car. So how exactly does this work, and where does velocity come into play? So this is the frontal view of that car as it's taking that turn. The centripetal force of the car is supplemented by the static friction of the tires on the road. There is also a force on the car, which is the normal force, which is pointing upwards, directly opposite to the mv force on the car. So if the velocity of the car is assumed to be v, the centripetal force has an equation of mv squared over r. R is the radius of the road from the center of the car. And then the static friction's maximum value is mu times mg, and mu is the coefficient of static friction. So for the car to safely make the turn, the centripetal force must be less than or equal to the maximum static friction value. By subbing in the earlier equations, you can simplify the equation, and you can figure out that velocity has to be less than or equal to the square root of mu times the radius times gravity. So this is the value that determines the maximum velocity of the car when it's taking the turn on a flat surface. Now, why do cars have more accidents in states with more rain and snow, such as New York? So, cars skid and tend to lose control more in these areas because rain and snow produce water and frost, which reduce the static friction present. As a result, the maximum velocity for the turn is also decreased. Cars speed up in these areas and they end up losing control. How do banked roads help this dependence on friction? So, this is a free body diagram of the same car on a banked road at an angle of theta. In this case, the fraction of the normal force points towards the center of the road, which is the n sine theta value. This value is enough to supply the centripetal force for the car. As a result, at the correct banked road, the equation becomes v is equal to the square root of gravity times r times tangent of theta. And because this dependency shifts to the normal force of the car rather than friction, friction is no longer needed to keep the car from losing control. As a result, banked roads are a good solution for cars when they're turning on curved roads. That's all from us. Thank you.